requirement. So he need, for example, a large clearance on the front side, or maybe on the front sides mean that at the basement he need large story height, so we need to increase the height of the column. Maybe if it is in the factory, so he needs some large opening, or the large wide opening in the front side so that the trucks may enter. So we need to consider everything in our mind. So it means that if the client he require a larger clearance on the front side, so we have to use larger spacing of column. If in our usual design we are using a spacing of maybe uh, 12 to 15 feet, maybe if our client's requirement is 20 feet or 25 feet, so we have to modify our design accordingly. So if a specific objective criterion can be expressed mathematically in form of objective function, then optimization technique may be employed to achieve. Actually, this is a little bit difficult. Optimization is an advanced topic that we cover at the master level, but I want to just explain that sometime we have to install very sophisticated or sensitive machinery on maybe first floor or second floor. In that case, we have to control the deflection or the vibration of the roofing system. So we require some extra stiffness. So it means that our structure member will be over strengthened or maybe a little bit uneconomical. Little bit uneconomical mean that here our first objective or requirement is not the economy. Our first objective is the deflection control limit. So if we want to control the deflection, we need larger section because deflection can be controlled by the moment of inertia. So in most of the cases, criteria or the criterion of minimum weight is almost always satisfied in our structure. In our structure mean that, for example, if we require a cross section maybe that might be I section or channel section. If we require the area 100 millimeter square, and if in the market we are having different option, maybe one option is 125 millimeter square and other option is 150 millimeter square. So we will select the 125 millimeter option because that is the lightest available option, which is more than our requirement. If we will select 150, this will also be safe, but this will not be economical. So we will always satisfy the minimum weight and cheapest option. So structure design must learn to arrange and proportion the parts of his structure so that they can be practically erected with and will have sufficient strength and reasonable economy. So we have to proportion. Proportion mean that I cannot use a beam of very large length. Maybe you can say I can design even though it is in the tension member, because in tension member design it will not buckle. We will see in our tension member design. But if we are using the very large length of the tension member, so that can vibrate if it is not subjected to the load. Just like you can see that the wires of electric pole. So if they are not loading, they maybe there is a sagging and the wire they can vibrate due to the wind load. So it means that the length should be restricted to a certain limit. And similarly, we should have the idea, for example, in the market, the maximum length of any section is available as 4 meters. So it means that I cannot provide a beam whose length is equal to 5 meters because maximum length available in the market is 4 meters. So we need to proportion. Proportion means that we need to select the spacings of the column and also the distribution of these beams carefully. So this we think we learn by experience. These important items called safety, cost, and practicality. So safety is always a priority in designing. Second, cost, and third is practicality. Practicality means that the structure we are designing, whether it is practical that it can be constructed or not. Simple is that if I am using a pipe section as a column, so I cannot weld a pipe section with a W section beam, which is not practical, which is difficult. It means that I should not select a pipe section or circular cross section as a column. I should select a column in such the cross section of the column in such a way that it can easily be connected with beam. So structure must safely support the load which it is subjected, safety criteria. Second criteria is deflection, and vibration should not be very excessive. I have already explained this. Designer must keep the construction operation maintenance costs at the lowest level without sacrificing the strength. Okay, uh, maintenance costs mean that uh, that can be the maybe painting of a structure in case of maybe bridges which are constructed above the canal or above the river, and other operational costs. Operational costs mean that if I am having the option of constructing a bridge by splayed girder, then I will not go for trusses, because in trusses the maintenance cost is more, because it is difficult to paint all the corners because there are a lot of joints there, lot of members which are meeting at the one point. So I need to select a structure in such a way that which is easy to maintain. Designer need to understand fabrication methods and should try to fit their work to the available fabrication facilities available. Okay, fabrication mean that mm, I must know that whether in my crew I have a skilled person who can weld, or I have a skilled person who can install the rivets. If I'm not having a skilled person who can install or fabricate the rivet, then I will simply use the bolted connection. So we must know that how the member they are being fabricated. Some designers lack in this very important aspect, and their design cause problem during fabrication and erection. So actually this type of the problem usually occur when we design the connection. Maybe at MSc level, you will learn how to design a moment resisting connection, how we can cut a beam to connect with the column. So generally the shape of a column and a beam should be in such a way that they can easily be connected. So designers should learn everything possible about detailing, fabrication, and the field direction of steel beside load, mechanics, and expected material strength. So actually, in this paragraph, he is summarizing everything. Summarizing everything is that being a designer, we must have a strong command on structural analysis. From the structural analysis, we can compute the maximum load effect or maximum internal resistance, which is the maximum bending moment being produced in the beam or shear force, or maximum compression or tension being produced in any axial member. If your structure analysis is weak, then if you are unable to compute the approximate or appropriate load effect, then your design will not be safe. Actual moment is coming out to be 300, but by mistake you have computed 200. It means that you are designing for the lesser load. Similarly, you must have a strong command on material strength. You must know that what is the yield strength. You must have the idea how the material behaves when it is yielded. So you must have the knowledge of strength of material. And then you must know how to compute the deflection in the beam. So further, the how a beam is being fabricated in the factory, how they are cutting it. Designer must have information concerning the transportation of material to site, labor condition, equipment for erection, problem at site, field tolerance, and required clearance at the site. Uh, Actually, this most of the problem occur during in mega structure, or a structure where the length of, for example, a plate girder, whose length is very large. For example, you have decided a plate girder length may be 10 meter, 10 meter means 30 feet. So you have to think, can you transport this longest length of 10 meter or 30 feet to the site easily? We have to see the road clearance, maybe the truck size where we need to transport. So if it is not possible, what we do, we will provide the beam in different span. We will provide some interior supports and we can reduce the length of the plate girder. The knowledge help to produce the reasonable, practical, and economical design. Okay, what are the procedure? Actually, I have already explained this procedure in my previous lecture, but here I will just rephrase it. So first of all, when we want to design mean that you can take any example of any structural member, for example, a beam. So in the design, I have told you that first of all, we have to see that what are the given information and what is the unknown. So collect and list all known data. Known data mean that we are having the architecture drawing, so we know that what is the length of the beam. Next is that what is the spacing of the column where this beam is being used, because from this information we can estimate the dead load or the live load. Dead load, we can convert it live and dead load as a UDL load on the beam. We must know what is the occupancy type of the building. Occupancy, whether it is a residential building, institutional building, or office building. From this information we can estimate the live load. And second thing, we need to see that whether the beam it is situated maybe on the first floor or maybe it is a top roof. So in this way, top roof we might have some water tank. We have to consider the load of water tank also. If any machinery is being installed on that floor, the load of that machinery will also come on that beam. And second information is that okay, I am going to design this beam of steel. So steel means that what strength of steel available in the market. Okay, second, maybe I have to consider that okay, at the end, if I have to use okay, what type of the end condition I have to consider. Maybe if you are considering the simply spotted condition, so during the execution you have to design a simply spotted connection. If you are considering the fixed ended beam, so your analysis will change accordingly, and during our construction phase we have to provide the movement resisting connection. And then we have to see the what are, if there are any other requirement, is there any limit regarding the depth of the beam. Sometimes architecture says that okay, use maximum depth of the beam equal to 450 millimeter. So we must not exceed that limit. We have to select a beam whose depth is less than 450 millimeter. Maybe he need to provide some false ceiling. There might be some other requirement, and there may also be certain other limit, deflection, and all these information are given. And what is the unknown? Unknown is only cross section. So from the given data, we will use the design equation. First of all, we will analyze. From the analysis, we are having the load effect. Then we are using the basic design equation. We are comparing the resistance of a material then with the applied load effect, and unknown will be the geometric properties or cross section. So what we do, we select a trial section. I will explain that how we can select this trial section. So for this purpose, we are having still LRF, this design aid. So I told you that you can buy this LRF design aid or the reference manual from Strength of Material Lab. So actually, trial section, when we want to select a section, for example, we require a W section whose area should be more than 100 millimeter. So we need to see that what are different trial section with different section available in the market, because we have to select this section among the available. But in our this particular design class, for just our practice, so we are having standard section. Standard section mean that these are some section which are manufactured or prepared as per AISC requirement. AISC requirement mean that he says that if we are having a section whose depth is equal to 300 millimeter, then for that section use the thickness of the web as a 10 millimeter, use width of the flange as 300 and thickness of the flange at 12 millimeter. It means that the size of the cross section, thickness of web, height of the web, thickness of the flange, and width of the flange, all are standardized and given by AISC. Why we are using these section? We are manufacturing as per dimensions given by or provided by AISC. Because if you are manufacturing that section, for that section, the geometric properties are already available. So we have already computed the geometric properties which are available in AISC steel construction manual. And these tables are also available in the book by Dr. Zahid Ahmed Siddiqui. So when we enter into the design phase, so I will share this table with you. After selecting a trial section means that I have selected a section, then whose area is minimum and the cheapest one, we will apply the capacity check. We apply two checks. First one is the capacity check or the strength check. Here, we will compute the maximum stress produced in the section due to applied load. If maximum stress or the load carrying capacity of section is more than applied loads, that section is safe. We will compute actual deflection due to applied load in that section because geometric properties are known. Against allowable deflection which are given by the code. So stability check is the buckling. If all checks are okay, then our section will be a final section and that is accepted. Then if any check is failed, then we will reject the section and we will select a heavier section and then apply all the checks. So until all the checks are satisfied. And then at the end, we will select a minimum or the lighter section which is satisfying all the checks. So this is again the summary of design. So at the start, design always start from the planning. So being a civil engineer, what a civil engineer is supposed to do or structural engineer is supposed to do, he plan, design and construct a safe and economic structure. And other requirement may be aesthetic and comfortability. So actually the design start from planning. Planning means that at the start, after collecting all the data, we will plan, and in the planning stage, we will decide the layout of the cross section. Layout means that we will select the spacing of the column and we will select the height of ceiling. And this will be, we will decide the preliminary structural configuration. Preliminary means that at this maybe start, we have selected the spacing of column maybe 3 meter, or you can say that maybe 18 feet. So at the end, if later on we need to change this preliminary configuration, we can reduce this spacing. We have to assume the loading condition. Dead load we have to calculate by the density concept. Live load we have to see take from the AISC table depending upon the function of the building. We select the trial section. So this trial section means that I am repeating what I have already explained in the table. From the load, we will carry out we analyze the structure by knowledge of structure analysis. We compute maximum stresses, and then we select the section. After selecting this section, we calculate the load carrying capacity and maximum deflection, and then we compare the maximum deflection and the maximum stress produced in the structure, again limits which are defined by the code or defined by the structural engineer. If all the checks are okay, then the structure will be final. If all the checks are not okay, we revise the design by selecting a heavier section. If heavy section is not available, then we need to reduce the loading. Actually, we cannot reduce the loading. So what we can do, we can reduce the length of the beam or length of the column by rearranging the preliminary layout. And then after designing the independent structure member like beam and column, we will join them. Join them means that we have to design the connection, whether we are going to join them by the rivet, bolt or welded. So we need to carry out at. And after the completion of the design, we need to make drawings, structural drawing. Actually, a designer, he communicate with the fabricator or manufacturer with drawings. He is not supposed to send him the drawings or all the calculation. He do not require your calculation or your all the data. He just require the cross sections or drawing, so that from the drawing he can fabricate or manufacture all the members. And then after preparation of the drawing, there might be a quantity engineer who can compute the quantity required for different type of the steel section. What is the total length of each member required? What will be the weight, so that he can place the order. So the stage of design is called preparation and design document. And after the preparation, he will estimate that how much will be the cost of structure. Okay, at this moment, uh, if you have any question regarding this design phase, you can ask me. If you are having any quick question, so you are welcome here. So anybody is having question? Maybe at the moment the lecture looks boring, but I believe that maybe in our next lecture, or maybe next week, when we will start the design phase, then the lecture will become more interesting. So roll number 100, are you there? 100, 2017 100, maybe not available. I need to note down his roll number.
Yes, sir. Hello.
कोई क्वेश्चन है आपका?
No, sir.
चलें ठीक है, मैंने यही कंफर्म करना था. चलें
All right,
माइक,
sir.
ओके माइक म्यूट करें. आई विल कंटिन्यू. Okay, next are the load combination. Actually, applied loads might be dead load, live load, earthquake load, and wind load. So actually, when in design phase, we have to consider all these load combination in a certain combination. Certain combination mean that, uh, for example, if I'm constructing a building in hilly areas where there is a snowfall, snowfall mean that I'm having a wind load also. And it means that in design phase, I should not consider all the dead load, live load, wind load together, or maybe there is earthquake load. If I have considered all the load at the same time, so my design will become very heavy, because I am designing for a heavy load. So it means that I have to consider the load into different realistic combination. Realistic combination mean that when a heavy wind is blowing, there might not be the wind, any snowfall. Or when a wind is blowing, so wind effect of the wind may be opposite to the gravity load. It means if the wind load is acting, then a full gravity load may not be acting. There might be have some uplifting effect. So earthquake maybe occur maybe once in a 50 year, and also there is no any possibility that the earthquake occur at the same time along with the snowfall, and building might be subjected at the same time. Building is subjected to the full live load, and its dead load is very heavy. It means that if I'm considering all the load, all the possible loads summing up, and they are acting at the same time, so my structure will be uneconomical and over designed. For example, in such a way that you are estimating that maybe you want to design a cup whose maybe capacity or the volume will be equal to 1 liter. 1 liter mean that 1000 milliliter. So actually you are designing in the spec that maybe you will order 4 cup of tea, you will have the 4 guests, and the 3 of the guests they will refuse to maybe take tea, so you have to drink maybe their share also, and then you place their tea also with your cup. So that's why you need a larger cup whose size may be equal to 1 liter. But actually there is a possibility maybe once in maybe 30 years or 10 years. So it means that you are computing the capacity of the cup unrealistically. So So it means that for the most of the time, you cannot drink the tea or take the coffee of 250 ml in a jug or maybe in a cup whose size is equal to 1 liter. So you are wasting the resources. So we have to consider all the load in different combination. So these combination actually are specified by AISC and ACI code. And these combination, they are based upon some engineering judgment, and they are also based upon field experience. So the, we have used different alphabet, there are different type of load that may occur on the structure which are represented by different alphabets. So factor of safety are also included in the load combination. So if we are summing up all the load without any factor of safety, this load will be service load. And if we are multiplying the load by some factor of safety, then that we usually do in LRFD, so we can do. So alphabet used in the combination mean different type of the nominal service load and numerical value with them are load factor that you can see in the upcoming slide. When intermediate floor have full live load, any type of the roof load may be considered equal to half of its normal service load. Okay, there is an example, unrealistic. Okay, it means that, for example, we are having a two-story building. In our first floor, maybe we are living, we are having furniture, and most of the time we are having the live load over here. So it means that the first floor will be fully utilized, fully in service, and we are having our routine life over there. And it means that if I want to consider the full live load on the first floor, I should not consider the full live load for the roof, because in the roof I do not have any furniture, so I have to rarely use the roof. And further, if I'm not having the roof access, then I can economize the beam structure and the other slab structure on the roof, because I don't need to design for the full live load. Similarly, in the institutional building, you are sitting in the classroom, maybe on the ground floor or on the first floor. So I must not consider a very heavy live load for the roof. So roofing beam may be the economical. Similarly, in case of maximum intensity windstorm, live load may be half. So when, for example, a wind is blowing, there is a windstorm, or you can say that there is a snowstorm or thunderstorm. So in that type, nobody will go to the roof. In that case, because when there is a storms, so in that case, the storms or the wind, they are produce the uplift effect on the building. So during the uplift effect, the live load can be reduced. So in that case, it means that the wind load in a load combination where we are considering the wind, we should not consider the live load full, because effect of the live load will be less. So last combination given afterward is a very important for uplift structure or reversal of the forces. So uplift and the reversal of the forces I will explain in our structure design portion. Wind load on roof is upward in majority of the cases, and if the downward gravity load is less, the structure may be blown up and sagging. Bending may change into the hogging and bedding. He says that, for example, if there is a heavy wind blowing and the door is open, in the door is open, the wind come to the room, and then it will produce the uplifting effect on our roofing system. It will tend to push the roof above. It means that it is countering the gravity effect. So in that case, we can reduce the gravity load or live load. So there are different type of the load combination. So for example, S is the snow load, H is the heat load. So roof life load, we might have fire load, earthquake loading, or any other type of the temperature load. So taken equal to 0 and wind load are taken from the previous code. So mostly in our plain area, we design the structure only for the gravity load, because earthquakes are not frequent and the wind is not, we are frequently we are seldom having the windstorm or thunderstorm. So actually these are the different combination. that we can consider to design a structure. So we design the structure for all these type of the combination, and out of this combination, which combination is giving the heaviest section, that will be the our structural component, which will be safely to carry the load. So first combination is only the gravity, or sorry, dead load combination 1.4. If we only need to design for the dead load, then we need to consider this. Where we will use this load combination, maybe for the parking shade, or maybe for the, you can so say that canopies or temporary structure that we design. So here, because we are not having the roof access, so in that case our structure should be minimum, and we only need to design for the dead load. In that case, we can use a factor of safety 1.4 instead of 1.2, because we are only using the dead load. Mostly we are using this second load combination, where we are increasing the dead load by 20%, live load by 60%, and if there is any extra roof load is acting, so LR means roof load, so that will be 0.5. And then if we are having the wind, so in that case we can either use the combination 1.2D plus 1.6 of the roof live load, or if we don't want to use the roof live load, then it will be simple live load or 0.8 time of the wind load. So we will see that what are the science or the basic concept behind this, because when the wind is blowing, so live load should be less. So 1.2D, 1.3 into wind load, roof live load is half. 0.9D into 1.3 W, here we are even not considering any live load. So these are the load combination for ASD. In ASD, actually we are not multiplying the load with any factor of safety. We are simply summing up the load which are referred as a service load. So actually this 0.75 live load, this 0.75 is not a factor of safety. This is just a percentage of the load we are considering, because factor of safety is always more than 1. So wherever we are using the wind load, we are not supposed to consider the live load. So these are the different design combinations which are governed by AISC. So basically, mostly we are using the dead load plus live load combination. In our truss system design that we will study in our design part, we are also using the wind load, and I will explain that how the wind load will affect structural design procedure. This thing you have already studied in your mechanics of material portion. So actually normally we use a mild steel in our structure system. In mild steel, carbon contents are from 0.15% to 0.29%. So if the carbon contents will be more, structure will have the high strength, but its ductility will be low. So the modulus of elasticity for a steel is normally ranging from 185 gigapascal to 230 gigapascal, but usually we use an average value of 200 gigapascal. So here, that's why we are using the factor of safety, because we always use modulus of elasticity 200 gigapascal, but actual modulus of elasticity may be less. So we may have a mistake in maybe calculating the exact value. So that's why we are capturing this problem by using the factor of safety. So there is a density of the steel is 7,850 kilogram per meter cube, or simply if you multiply with the G value and divided by 1000, so it will be 77 kilonewton per meter cube. Unlike concrete density is low, which is 23.6 kilonewton per meter cube. So most of these structural steel fall into mild carbon steel and simple steel. So MS means mild steel. So hot roll structure shape may be made to conform. So these are the different type of the steel. So all the steel structure shape, maybe I section, channel section, angle section, they are made of, might be made of this steel. So A36M is the steel. A mean that actually A is the chapter name in ASTM which deal with the metal. So A36M, 36 is the yield strength in KSI and M stand for mild. So A36M steel mean that a steel which is conforming to the specification given by ASTM A36M. So A is a chapter name, 36 indicate that yield strength in KSI, Kips per square inch. If you, there is a one very simple conversion you might remember. You can note down also if you want. 1000 psi pound per square inch is equal to 7 megapascal, or 1 megapascal is equal to 145 psi. So if you are converting 36,000 psi or 36 ksi into megapascal, so 836 still mean that this yield strength will be equivalent to 250 megapascal. And actually we are having another steel which is A529. Here 529 indicate the yield strength in megapascal. And similarly we are having this high strength steel which are available in market. So along with the steel section we are also having the steel sheet, roof sheet. They are used for the roof sheeting, they might be corrugated. So they are made as per ASTM standard A606. This standard they specify that what should be the thickness of the steel sheet, what should be the corrugation, and all the other specification. Boards they are made as per this standard A307, 825M. 825 mean that a board whose ultimate strength is yield strength is 325 megapascal, which is made of mild steel. A40M is indicating a bolt whose yield strength is 40 ksi. So sometimes both designations are used. So how I have remembered that which designation is in megapascal and which designation is in psi. If the number is less than 100, I memorize by this, then the value is in kips per square inch. If number is above 100 or in 3 digit, that might be in megapascal. A40 mean that yield strength 40 ksi. 325 yield strength 325 megapascal. So in most of the cases in our steel structure design and the steel which is available in the market, we are having two steel. One is 836M, that is most widely used. 836M mean that a steel whose yield strength is 36 ksi. M mild. So for this steel 36, if we are converting into megapascal, just divide 36 by 0.145, because 1 megapascal will be equal to 0.145 ksi or 145 psi. So this will be equal to 250. So you have to memorize this value. You shall never be provided. In the examination, maybe it is simply mentioned use 836 steel. 836 steel mean that a steel whose yield strength is 250 megapascal and ultimate strength is 400 megapascal and modulus of elasticity will be 200. And for the electrode mean that we are using the electrode rod to weld different component of steel. So for the electrode we are using the symbol E. E represent the electrode. 60 represent ultimate strength. This is not yield strength. In electrode weld never fail in yielding, they fail due to rupture. So 70 represent that an electrode whose ultimate strength is 70 psi. So letter E denote the electrode, 2 digit indicate ultimate tensile strength in KSI. So sometimes we are also having the designation in SI. In SI we are having 3 digits. So for example, E95 electrode, an electrode whose ultimate strength is 495 megapascal, and actually E95 is same as of E70, because if you convert 70 into megapascal, dividing the 70 by 0.145, so you will have this answer. Okay, here I would like to maybe have a break, and break is of maybe 10 minutes. In the meantime, if you are having any question, you can ask me. So anybody is having any question? So if there is no any question, so yes, yes, Uzair.
सर
पहले
जिस
यार,
तरह हमारे पास
listen first, listen. You need to use the raise in hand option. Then I will ask you to open your mic and ask the question. Yes, Uzair, now ask question.
सर जिस तरह हमारे पास वो A36 के आगे M लिखा हुआ था, और अगर सर आगे कुछ भी ना लिखा हो तो वो
एक्चुअली वो होता नहीं, वो माइल्ड ही होगा एक्चुअली। अगर ना भी लिखा हो तो कोई मसला नहीं, बिकॉज इन सिविल इंजीनियरिंग प्रोजेक्ट मोस्टली we have to use mild steel because we need large ductility. You understand me? So even
yes,
though if it is not mentioned M, so it is understood that most of the cases it will be mild. In mechanical component, we have to use high strength steel. So high strength steel, they are not mild. So most of the civil engineering related steel structures or steel rebar, we have to use mild steel, where the percentage of the carbon contents are between 0.15 to 0.3%. You got it?
Okay sir, yes sir.
Okay. तो इंशाल्लाह मैं अभी अपना माइक भी बंद करता हूँ, एंड वी विल स्टार्ट 2:15 पे दोबारा स्टार्ट करते हैं, ठीक है? 15 मिनट की ब्रेक कर लें। CR, can you hear me? CR?
Yes sir.
Okay, may I start the lecture again? So you also see the slides?
Yes sir.
Okay, good.
Yes sir.
Okay, next we discuss that what are the different type of the structural shapes available. So number one is hot rolled structural shapes. We already know that what are the hot rolled section. Actually, these are the section which are made at hot state. So we are having the molten steel. First of all, we melt the steel billets and we pour the molten steel into the molds, and then we attain the shapes at hot state. So that's why these sections are called hot rolled section. So actually these are the different shapes or the type of the section which are available in market. For example, this section, so this is referred as W section. So sometimes it is also called I section or wide flange section. So in this section we are having the slope or the angle between web and the flange is exactly the 90-degree, or the bottom face is at 0-degree, or a flat surface. So this is called W section. So we might have a different size of this W section available in market, which are having different thickness of web, height of web, different width of the flange and thickness of flange. Similarly, we are having another shape which is referred as S shape. So S shape is similar to W section. They are also referred as I section, but their bottom face of the flanges, they are tapered, and they are tapered and with an angle of 16.7 degree. So we are referring this section as S section. So S section is mainly we are used as a beam, or we can also use W section as a beam. So we will see that what are the advantages and disadvantages, but normally W section and S section both are I section. So just S section with sloping face and W section wide flange I section with a flat bottom surface of flanges. Similarly, we are having angle section. So angle section which is comprised of two legs, we might have both legs equal in length or different with different length. Similarly, we are having channel section. So channel section actually this is half of, you can say half of the S section. So in channel section shape is just like the C, alphabet C of a C, and again we are having tapered bottom surface, or the bottom surface or face is tapered with an angle of 16.7 degree. We are having T section. So if we are cutting the S section or W section, maybe along its x-axis, so we might have T section. So just you might know that we are using TR and girder, so that is similar. And we are having HP section. So HP section, you can say that that is the inverted W section, but that is different from W section. So in HP section, actually the thickness of the web is larger as compared with the W section and S section. And also the height of the web or the length of the web is smaller as compared with the S section and W section. So actually we prefer W section and S section in beam case, where we require larger depth or larger moment of inertia. But the HP section is normally, or which is also called H or head section, so which is used as a column, because in the column we are having concentrated force which is acting or passing through the web. So in that case we require a larger thickness of web. So the two basic difference, depth or depth of the web or height of the web is lesser in HP section as compared with the S and W section, and thickness is more. Further we may have pipe section or hollow circular section, which can be used in the column. We may have rectangular hollow section. We may have uh, solid rectangular section, solid circular, or flat plates. So first of all, W shape. W stands for an I section with wide flange. So W section is the I section with wide flange. The cross section is doubly symmetric in form of letter I. You already have seen in the previous slide. And the width over depth ratio varies from zero point 0.3 to 0.1. So 0.3 to 0.1 mean that, again if I will come back to this, so the flange length is equal to 30% to the 100% of web. It means that in most of the cases the width of the flange is more than 30% of height of the web. So in other words, the width of the flange is always less than total depth of the girder. So in market actually we are having maybe 10 type of the W section. So all 10 type of the W section or maybe more, all 10 sections they are having variable or different thickness of the web, different length of the web, different thickness of the flange, and different width of the flange. So if we are placing the order, so actually what designation we have to use? What we ask to the vendor that what size of W section you want to buy or you want to order. So all type of the section which are having some particular size, they are designated by a standard symbol or standard designation. For example, in US customary designation, US customary mean that FPS. In America, they are still using the FPS system. So in FPS, a W section is designated, for example, as following: W16 into 40. So W represent a section, an I section, W section, or with wide flange, or a wide flange I section. So letter W represent that this is the I section with wide flange, and the first letter with W, this represent total or nominal depth of section. Nominal depth means that the depth of this section is 16 inch, and the second designation represent weight per unit length of that section. So it means that if we are having W16 into 40, so this is US customary designation used for a wide flange section whose nominal depth is 16 inch and weight is 40 pounds per feet. So why we need the unit length? Because if we know the unit length, we can easily compute total weight of the section required for the construction. Because at the end we have to make a bill of quantity, so we can roughly estimate the cost of the structure. Along with US customary, we can also represent an I section, or we can give the name in term of SI units. So in SI units, so an equivalent SI units for this section, W16 into 40s, they are given over here. So equivalent units are W410 into 60. So here W represent a wide flange I section 410, which is having nominal depth 410 millimeter, and 60 is weight of that section, which is 60 kilogram per meter. So kilogram force or simply kilogram you can use. So actually what does it mean by nominal? Actually the nominal means that the actual depth of this section may be 415 millimeter or maybe 405. So but a nominal depth, we are referring with a nominal depth which is 410, but the actual depth may be 408 or 412, and 60 is the weight of this section in kilogram per unit length. It means that if we are having a beam whose length is 5 meter, so if the weight of 1 meter is 60, then the weight of 5 meter will be 300 kilogram. So kilogram force, we can convert the weight which is in kilogram into the Newton by multiplying with 9.81 and divided by 1000. So in this way we can convert the force from kilogram per meter to kilonewton per meter. So obviously this is a dead load, so the units are in so nominal height is rounded off height to be used for common use. Just I have explained nominal depth if it is 410, but actual maybe 408 or 413 or 12. So S shape is similar to W section, but only difference is that uh, we are having tapered bottom surface, or the bottom face or the inner face of flange is tapered with an angle of 16.7 degree. So thickness of the flange is not uniform. So this is also doubly symmetric I shape. So it is previously called standard I beam or American standard beam section, but now we are referring as a S or doubly symmetric I shape section with slopy inner surface. Inner edge of flange has a slope of 16.7 degree. Standard designation is the same. If we are reading this section as 510 into 112, it means that we are having an I section with tapered inner face with nominal depth 510 millimeter, and weight of that section, unit weight is 112 kilogram per meter. In that case, width and the depth ratio varies about 0.25 to 0.85. It means that the BF value flange, the width of the flange is always ranging from 25% to 85% of depth. So they are always mean that the width of the flange will always be less than depth of the section. Then we are having M section. Actually, what are the M section? M section, they are also I section, which are neither W section or nor S section. S section mean that all type of W section and S section, these are standard. Standard section mean that if I know the designation of any section, then I also know the dimension of all the section. So if this section they are not manufactured as per um, standard, then we are referring as M section. M section is the non-standard or miscellaneous I-shaped section. So definition is the same. M310 is 17.6. Miscellaneous I section whose nominal depth is 310 and the weight is 17.6 kilogram per meter. So they are a little bit lighter section which are used to carry a lighter weight or for the temporary construction. Similarly, we are having this C shape or the channel section. So in all type of the channel section, the inner faces are tapered with an angle of 16.7. So inner flange slope is 16.7, similar to the S section. So previously they were called as standard American channel section, but now simply the channel section. So a designation, for example, a C150 a C150 into 19.3. So this is a channel section whose nominal depth is 150 millimeter and weight is 19.3 kilogram per meter. MC miscellaneous channel section. This is a channel section which are not manufactured as per standard or specified by AISC. Channel not classified as a C shape, previously called shipbuilding or miscellaneous channel. Shipbuilding because mostly it is used in the marine engineering to make these ships. Then we are having angle section. So in angle section, we may have a single angle or we may use angle in combination. So this is the double angle. So we are having two legs of angle section. One may be referred A, another may be B. So A and B, they may be same. If the both length of both leg is same, this is referred as equal angle section. So if A and B, they are not same, if the both leg they are of different length, then this is referred as unequal angle section or unequal leg angle section. Here, the designation for an angle section is different from I section and channel section. So here we are having three parameters or three digits or three numbers. L represent angle section. Okay, first two dimension they represent the length of their legs. So this is an angle section whose one leg is 89 meter long, second leg is 70.76 millimeter long, and the third digit or third value is thickness of that angle section. So if we are having equal leg means that this will be 89 into 89. If first two number they are same, that section will be equal leg or equal leg angle section. If the first two digits they are having different values, then the larger digit is always written the first. So L89 into 76 into 12.7 mean that an angle whose maybe length, larger leg is 89 meter, shorter leg is what I must say 76, and thickness is 12.7. So weight is not given here. Actually, for the weight, what we may do, the weight can be consulted from the LRFD manual or the specification or the steels. We are having some table which are available in steel design aid, which are called steel sectional properties table. So I'm copying here in my folder. So maybe I will show you in a short while the what are steel section. And so double angle section are the combination of two angles with longer and shorter side close to each other. So double angle section, we use a digit 2LS. It means that double angle, two angles. So what if I'm just writing here 2, and here small subscript s. So it means that it is two angles which are used in combination. Longer leg is 89 millimeter, shorter leg is 76 millimeter, and thickness is 12.7. So double angle, we are using two. We may use S symbol here or not. Sometimes we may use symbol S, and sometimes we may not write if. But that is the 2LS represent. We are using the two angles in combination, where the larger leg dimension is 89 and shorter leg dimension is 76 and thickness is 12.7. Then we are having T section. So in T section, so we are having T shape. So T is actually the half of W section. So their designation will be same as of W section, but we are using the digit T instead of W. So these are called structural T's. These are obtained by splitting, cutting the W or S section from the x-axis, or M shape also. So they are referred as WT. WT means a T shape which is obtained by cutting W section. ST, which is obtained by splitting S I section, and MT, which is obtained by splitting the M shape. So a WT means that a T section which is obtained by splitting the W section, whose nominal depth is 205 millimeter and the weight is 300 kilogram per meter square. So what I can say, it means that, just for your reference, this W section is obtained, this is obtained from this 410 into 60, because if I'm splitting up the depth into half, so half of the depth will be 205. So if I'm using the half of the section, so for the half of the section weight will also become half. So this WT section is made by splitting this W section into two parts. Then we are having the cold form section. This cold form section, actually these are the steel sheet. We cut the steel sheets into a different size, and then we press to obtain different shapes. We can press the edges to make it the channel shape. We may have some projected portion, and at the end here we may have simple Z section with some projection. We may have the head section, or we can make any type of shape from steel sheet. So normally these are also called cold work section or cold form, because we are bending this steel sheet at room temperature to make any desired shape. So usually they are also referred as thin walled section. Next is the built up section. Built up section means that which is not a standard section or not a single section. So we are making using this section in different combination. If I'm joining two section to make as one section, then this section will be called as a built up section. So built up means that I have made by myself by joining two different sections. Okay, example is that I want to select a section, maybe here. I want to select a W section whose area is 200 kilogram. Sorry, whose area is 200 millimeters square, just for example. But that section is not available in the market. We may have a section, I section, but the weight of that I section is 300 kilogram. If I'm selecting the 300 kilogram, 300 millimeter square section, so it will be heavy. It is more than my requirement. If my requirement is 200 millimeter, okay, I could have selected 210 and 220. but I will not go for 300. So in that case, I am having another option. The vendor says that, okay, I am having a channel section whose area is 100 millimeter. So it means that the area of two channel will be 200 millimeter. So I can use two channel in combination. I can join them by some welding, by some mean that we shall discuss, by some lacing member to make as a one member. So this member that I have made by connecting or joining two channel section to meet my requirement is referred as built up section. So similarly, we are having this section built up section which is made of four angle section which are separated at a certain distance, and maybe their outer surface it is connected by some steel sheet. So why we need built up section? We need the built up section maybe due to two reasons. What are the two reasons? Two reasons might be if a heavy section is not available to market in the market, or we need a lighter section with more moment of inertia. For example, how I can explain? Let's suppose we are having, let me duplicate this slide. Okay, just see here. These are the four angles which are placed very close to each other. And these are also four angles which are sparsely placed. Actually, if I ignore this connecting member, these are the thin steel bar which are used to join all four angles. So actually the area or the weight of this four angle is almost same to this four angle. Or maybe if we can consider some weight of this, we ignore the weight of this connecting element. So area or the weight of this four angle is same as of this. But this section, it is having larger moment of inertia as compared to this. Because in this case, the depth and width is less. But here, depth and the width is more. So we have placed this angle at a larger distance from each other in order to achieve larger moment of inertia. So built up section, actually this is a section that we made by joining two lighter section or two section at a different interval or maybe placing close to each other. So we can join this member by using different technique, by using lacing. These are the thin steel member, or by using stay plates. Stay plates mean that there will be a plate between two sections which are connecting with each other. We will discuss in detail in our compression member design. So why we are making? We are making the built up section only due to two reasons. Number one, if a lighter section is not, a heavy section is not available, then we join two member to make an heavy member, or sometimes our load is less. We need a lighter section which have more deflection control, or which is having the less deflection. In that case, we need a larger moment of inertia, larger depth. So how we can achieve? We can use a section, a lighter section, we can place at a larger distance to achieve more moment of inertia. So this was the example. Next is the cladding. So cladding, actually these are the exterior covering of structural component of building that are made up of steel section is called cladding. So cladding, actually these are the used for aesthetic purposes or for the architecture that we are using to hide the interior feature of steel structure. So exterior covering, that are the cover that we provide to our steel structure member to make a beautiful architecture. For example, You have seen Sydney Opera House building in my very first lecture. So inner surface is a truss surface. They have hidden the inner surface by using the cladding. So covering may be made up of reinforced concrete or wood or maybe aluminium or maybe any other architecture. So at the moment, I would like to welcome some answer. If you are having a question, if you are having some question, you can ask me, any student. So let me check that whether the steel table they have been copied in my folder or not. Yes. Okay, Sia, just let me know. Can you see this table that I have shared?
Yes, sir.
अच्छा कोई अच्छा सा पेज हो सीधा हो वो मैं दिखाना चाह रहा हूँ. Okay, this table. Actually, if you will open up the LRFD Design Aid by Dr. Zahid Ahmed Siddiqui, it is containing various table and charts. So at the start, we are having table for steel sectional properties table. We are referring as a steel sectional properties, where all the standard section they are placed. So these standard section are the section which are specified by AISC, American Institute of Steel Construction. So actually he has given different designation. For example, here they have listed a various section. For example, W760 into 852. This is a section whose W section, wide flange I section, whose nominal depth is 760 and weight is 582 kilogram. So it is an equivalent. US customary designation is also given. So 760 millimeter in inches, that will be W30. So 30 is the nominal depth in inches and 391 it is weight in pound per feet. So let me move to this table. Yes, this table also. So actually here in the AISC they have listed maybe many I section with different designation. It means that in their library they might have 100 W section. In market all the 100 they might not be available. So a simple example here is that if I'm considering the example of 4W 610 into 153, so this is the section. If in Pakistan any factory they want to fabricate this section W610, so this section will have some particular value. So the area of this section will must be 9,500. So it means that for this section area cannot be maybe change. And how they can achieve this area if they are having this standard dimension. So these dimensions are specified by AISC. If any factory they want to manufacture a section which is W610 153 or a section whose nominal depth is 610 and the weight is 153 kilogram per meter, then they have to satisfy this condition. So in this table the depth is given. So actually for this actual depth is 622. So this 610, this just represent nominal. Nominal mean that that is used just for the reference. Actual depth may be different. So actual depth of this section is 622. It means that if we want to check what is the actual depth, we need to consult this table, which are the steel sectional properties table, which are given at the start of our steel construction manual. So you can see that in this group, all section they are having nominal depth 610, but they are having different weight. But all are having same nominal depth, but their actual depth is different. So actual depth is for this section 622 and for the bottom section 602, but they are classified in a group of 610. And next, if you want to check that, there is no any column for the weight, so weight can directly read from here. So second digit is the weight, 140 is the weight kilogram per meter. And if you see that in this column, which is flange width, so flange width, okay, at the top it is also mentioned here. So bf value is the total flange width. So bf value for this section is 229. For the same section, the thickness of the flange is 24.9, and the same section is having thickness of web as 14. And similarly, there are other some values that I will not explain here, that I will explain when we will use them. And then for the same section, you don't need to compute moment of inertia about x-axis and also about y-axis. We are also given the radius of gyration about x-axis, section modulus about x-axis and y-axis, and all the other radius of gyration. So actually, what is the advantage of using a standard steel section? A standard steel section means that if we are using a section which is a standard section specified by AISC, so we not need to compute geometric properties by ourselves, because if it is conforming with AISC, so we are provided with all the geometric properties. So in AISC library, there are 100 sections. But may, for example, if I am the manufacturer, I may be manufacturing 100, only 10 out of 100. Similarly, if we are having W 416 to 106, a W section whose weight is 106 kilogram per meter, and nominal depth is 460. Actual depth 460, width of the flange will be 194, thickness of the flange will be 20.6, and thickness of the weld 12.6, and BF and K value are different. K value is the distance from the top to the some point. So I will not explain here, you will get confused. So I will explain in a chapter of plate girder. For the time being, we must know what is the area, what is the depth. Okay, here the depth is the total depth. Nominal depth means that from the top face of the flange to the bottom face of the flange. If you want to compute the height of the web, then we need to subtract 2 times thickness of flange. Subtract thickness of the thickness of the flange from the one side and one from the other side. So it means that if some vendor want to make this section, he cannot change this dimension. Otherwise, if he is changing this dimension, he want to make a section whose nominal depth is 460 and the weight will be same. But if any one of the dimension will change, then this will be referred as the M section, not W. M means miscellaneous, which is not as per standard. Similarly, in the same tables, at the end we might have S section. S section are given at the bottom. So M mean miscellaneous, which is not as per standard given by AISC. S section, I section, which is having sloppy inner face, whose flanges are tapered. 510 is the nominal depth and weight is 143 kilogram per meter, and their all dimensions are given here. So similarly, I would like to show you the angle section. Regarding these tables, any clarification I may explain. Is having question? No, okay. Actually, I'm trying to find out the table for angle section. If they are with me, I can show. No, they are not available at this moment with me. But anyhow, if you are opening LRFD specification, then you can check from there. So, any question at the moment? If there is no question, I would like to have 5 minute break. So I will start again after 5 minutes. Okay, now we will start our lab portion. So in lab portion, actually what we are supposed to do, let me explain. So in lab part or in the design, actually there's no lab part. This is called the design class. In design class, you will have a complete hand-on experience of a complete truss roofing system design. Truss roofing system design means that you are supposed to design actual roofing truss system. So you will get the practice or the idea if you want to design a roofing system for any factory or maybe for any residential building or maybe any institutional building in the hilly areas or maybe in any parking shed for any purpose. So what are the different steps, how you can estimate the load and how you can analyze the stress and then how uh, what are different design criteria, what are the different components that you need to design, and at the end you will prepare the structure drawing as well. It means that it will give you the complete practice or complete idea that when we want to design any structural component or any roofing system, so how we collect the data and how we design the various components. So actually in this particular lab design course is designed or the curriculum is designed such a way that students should get a hand-on experience for the design of a truss roofing system. When I talk about the truss roofing system, it means that I need to design the trusses and then the roofing system, made the sheets which are used to cover up the uh, trusses, and then what are the different components which you have to design in a roofing truss system. So first of all, we must know that what is a truss and what are the properties. So truss is a frame structure in which all members have axial forces due to following facts. So maybe you might have an idea or you might know the definition of the truss from your knowledge of mechanics of material and structural analysis. So if I want to define the truss, definition might be different. Actually, you need no need to memorize the definition. You need to understand. So a truss is a structure where which is comprised of which is comprised of line element which are concurrently connected at different points. So actually the truss is comprised of cylinder element or line element which are concurrently joined at different points or at a joint or center line of all the members they are meeting at one point. So another way is that in this configuration of the truss we must follow a triangular pattern. So you can say that a truss is comprised of line element or the cylinder element which are arranged in triangular pattern and concurrently joined. So all members must have the triangular configuration. If in any segment triangular configuration doesn't exist, that will not be a truss. So all joint of trusses are actually they are semi-rigid or fully rigid. However, theoretically we can consider these joints are joint as a pin joint. So actually in trusses we only have axial forces, compression and tension. Why? Because in trusses load is only acting at joint. So when the load is only acting joint, load is not acting transversal direction to the member, so we are not having any bending moment. So in trusses also actually the center line of all the members they are meeting at the same point at any joint. So it means that we are not having any movement. If you are taking the summation of the movement at any joint, so since the forces are passing through that joint or that center point, so the moment will be equal to 0. So due to the same reason, even though if you are connecting different member by welding connection or maybe riveting or bolting, actually you are not providing the pin. So even though they are connected with the welding or maybe by bolting, so joint is considered as a pin joint. Why it is considered as a pin joint? Because summation of the moment is 0. Why summation of the moment is equal to 0? Because center line of all the member which are being connected at a joint is valid and provided that a requirement given in number. What are the requirement number 3? Actually, this is supposed to be point A1, 2, 3. So here number 3 you can say C and number 4 D. So why we are considering joint as a pin joint? Because centroidal axis of all member meeting at a joint must intersect at a single point. So center line of all member, they are intersecting or passing through a common point. So load is only applied at panel point. Panel point means at joint only. In trusses, you already have analyzed the trusses where load is only acting at joints. These joints are also referred as a panel point. So following are the comparison between rigid frames and trusses. Where we use the trusses? Actually, truss, they are also beam. For example, if you are having a truss, let me explain from, yes, you can say this truss is also a beam. You can say that where the depth of the beam is this one. The length of this member is equal to depth of the beam. And the length of the beam is equal to length of truss. Actually, and we are not having material here. So if we are cutting the material from here just for the economic purpose, so that become trusses. So trusses are used where the span is very large and we want to reduce the weight of the structure. So we want to reduce the weight of structure, so we are using the skeletal member. But in a typical hot rod section, we cannot, if we are selecting a larger depth, then we will have lot of material available between these triangular segments. So what we have done is mean that we are making a beam with the help of a skeletal member. Why we are making this beam? Because we need larger depth. Why we need larger depth? Because we will have more moment of inertia and the deflection will be less. Because if we want to achieve larger span, in larger span deflection will be more. So deflection is controlled by a larger depth. So in that case, just to make our structure economical, we go for trusses instead of hot rolled beam section. So these are some comparison. Joints are considered as having frictionless pin in trusses with no movement at the member end. But so in actually only axial forces are existing in the trusses and we are assuming the movement at the joint is equal to 0. But in case of rigid frame means that movement existing, fixed, rigid means fixed. We may have some negative movement at the end. The forces in case of trusses are only axial and hence member are equally stressed throughout their cross section. So axial forces mean that we assume axial forces is passing throughout the length of the member. So if we cut at any this section at any point, so the uniform stresses are acting in the truss along the length because forces are axial. But this is not the same. But in case of the rigid frame, where the load is acting in transversal direction means perpendicular to the length. In that case, the stress will not be same throughout the length. Why? Because when you plotting the shear force and bending moment diagram, so moment is the function of the length. So moment distribution of the bending moment and shear force is not the same throughout the length. So it means that where the moment is more, the flexure stresses will be more. and where the shear force is more, shear stresses will be more. It means that the bending stress and the shear stresses, they are not same throughout the length in that case. So in case of the beam also, one side is subjected to compression and other type is subjected to compression and vice versa. But in case of trusses, if one member is in tension, so entire length of the member is subjected to uniform tension. And similarly, if a member is subjected to compression, so entire length of truss member is subjected to compression. Because of the above fact, design of member in case of truss is economical and compared with the member of rigid frame. Actually, if I want to design a rigid frame means a beam. In rigid frame is comprised of beam and column. If I want to design a beam, so in beam there are two type of the internal forces acting: shear force and bending moment. So there are shear stresses are being produced and there are bending stresses. So bending stresses mean that one side will be in tension and one side will be in compression. It means that if I want to design the beam, I need to consider the compressive stresses, tensile stresses, and also shear stresses. But in case of trusses, I just only need to consider either compressive stresses or tensile, so our design will be economical. So next they are the type of the truss. Generally, the trusses are categorized into two types. Type 1 trusses are preferred in those areas where snowfall is common. And type 2 trusses are used in, actually this is hot climate. So type 1 truss, they are used in hilly areas, so they will be steep. And type 2, they will be less steep. So type 1 trusses where the inclination of top chord is between 10 to 60 degree. So why we are having this steep slope, for example here, so this is the angle. So the angle between the top chord and bottom chord will be 10 to 60. Why the angle will be more? Because during snowfall can easily be drained. If thus it will not be steep, so snow will be deposited on the on the top chord. So there will be some extra load is coming. So extra load may cause the failure of the truss. This may also be preferred if bending moment are larger near the midspan and zero at the end. So actually to reduce the load, we can also adopt this type of the trusses. So in type 2, angle are less than 10 degree. So mostly they are flat trusses. So these are used. Why we are still using the 10-degree angle? Because we want to drain the water from the top surface. So these are used in the hot environment or in our rural areas, maybe in cities. So this is a simple truss. So definition of truss is that distance between the support is called span or length of the truss. Total height topmost, this is called crown. Distance between the topmost point to the bottom point or the bottom chord is called rise. So rise is the total depth of the girder from the bottom chord to the topmost point. So this is called top chord. Bottom member is called bottom chord. These are the vertical member. And if we are having, these are diagonal member. Interior members are either vertical or diagonal. So this is the top chord. This is flat top chord and this is bottom chord. So this is a king post truss and this is queen, which is used if the length is less than 12 meter. If the length is more than 12 meter, so we use an interior segment with maybe a rectangular shape but in triangular pattern. So these are different type of type 1 truss. This is just configuration. You can say this is called thing. This is thing. So name are given just due to the with reference to the arrangement of interior member or diagonal member. This is compound thing called French truss, fan truss, because distribution of the diagonal members are just like fan. Subdivided. This is some sort of the combination of truss uh, arch. So member may or may not be linear, they may be circular, a little bit. Okay, now we are having different type of truss. With this is the classification with reference to the forces which are being developed in the trusses. This is difficult to maybe if you need to memorize, you just understand this definition. If the forces in the diagonal member are compressive and forces in vertical member are tensile, all vertical member are subjected to tension forces, and all diagonal member they are subjected to compressive forces, then the truss will be Hove. And opposite to will be Pratt. In Pratt, diagonal member will be in tension and vertical member will be in compression. So here is the Hove, because I want to give this, yes. Actually, this is the Pratt truss and this is Hove. Distribution of the, just the pattern of the diagonal member is reverse. Actually, in roofing system, load is acting on the top. Maybe I would like to explain by sketching. Okay, let's suppose if a force is acting on the top chord like this way, as I have explained. So when this force is acting, actually this force, it is trying to compress this vertical member. So it means that due to top, if the load is acting on the roofing system or the top chord, then this member will be in compression. And what will happen? This member, the bottom chord, it will tend to sag like this. When it will be sag like this, so sagging will cause this member to elongate. So this member will be in tension. So in case of the Pratt truss, the vertical member are in compression and diagonal member are in tension. But on this end, if we are having this configuration, so in this case, so Hove truss, in this Hove truss, what is happening? If the load is, sorry, if the load is acting over here, let's suppose, at this point, so you will see that this load is trying to compress this diagonal member. But when the bottom chord, it is sagging, so it will tend to elongate this vertical member. So all vertical member, all, they will be in tension, and all the diagonal member, they will be, maybe I have wrong. So in Pratt truss, all vertical member will be in compression and diagonal will be in tension. But in Hove, all vertical member will be in tension and diagonal will be in compression. Okay, one more thing. That doesn't mean that this truss will always be Pratt. This truss will become Hove if the load is acting at the bottom chord. In case of the bridge. In case of the bridge, when the load is acting, then this member will be in compression and this member will be in tension. So it means that the definition is not based upon the configuration. Definition is the behavior of the forces which are being developed in the interior member. So difference between these two trusses is only the orientation of the diagonal member in relation to the applied load. Then we are having the variant truss. In variant truss, diagonal alternative diagonal members are they are oriented alternatively. Maybe one diagonal member will be in compression and one diagonal member will be in tension, compressions. So this is the variant truss, where diagonal members are alternative. One is in this direction, other is in on this. One is facing left, other is facing right. Facing left, facing right. Facing left, facing right. So members are provided alternatively. But in case of flat trust, all on the one side, all the diagonal members are facing one side, and the diagonal members which are on the other side, which are facing on the other. But here the orientation is different. So if they are placed alternatively, this will be the variant truss. Okay, this is the actually these are the truss of type 2. In type 2, the angle is less than 10 degree. So in case of the type 2 trusses, actually the first vertical member will have sufficient length. But in type 1, slope directly start from the support because we need high inclination. This type of trusses are used to carry heavy load where the less drainage is required or there is no any snowfall. This is also wherein we are not having any vertical member but diagonal member, they are placed alternatively. We may have cantilever truss. Okay, I guess I have to stop here because next topic is very long. So I would like to start the topic, remaining topic next time. So if you are having the question at the moment, you can ask me. I know that today's lecture will be might be very boring, but no problem during in the next time. So we are entering to the basic or main design phase. So lecture may become interesting. Yes, Uzair Shafiq, please ask the question.
सर हमारे पास अगर ट्रसेस में ट्रायंगुलर जो है अरेंजमेंट ना हो तो उससे फिर क्या फर्क पड़ेगा?
वो अनस्टेबल हो जाएगी, वो ट्रस नहीं होगी, फिर उसको फ्रेम कह सकते हैं. अगर वो ट्रस भी होगी दैट विल बी अनस्टेबल बिकॉज डिग्री ऑफ
फिर हमें रिजिड जॉइंट प्रोवाइड करने पड़ेंगे.
नो, लिसन टू मी, दैट विल बी degree of indeterminacy will be negative. In that case, the member may be designed as a beam. In that case, the forces in the member may not be the axial forces. It may be subjected to the bending moment. So in that case, we have to design that member as a beam. Or वो beam mean that if the bending moment and shear force are being produced in any member, then that member will not be regarded as a truss member. That will be a frame member. Yes, it's clear. If not clear, you can ask me.
सर वो फिर एक बीम और ट्रस का या फ्रेम और ट्रस का कॉम्बिनेशन बन जाएगा स्ट्रक्चर हमारा.
Yeah, you can say yes, you can say. Anybody else is having question? Anybody else? Okay, if you are not having any question, so I will share this slide in the evening with you. I will upload on the MS Team. So if there is no any question, so I will conclude the lecture. So inshallah I will see you next time.